almost a minute late. I do have to make sure that it's actually going though. So today we're just doing a review, and the form that review is going to take is simply just taking an old final here for a similar class, not exactly the same, but we'll do as many exercises from that review, from that final as we want, and then we'll continue with another final unless there are questions. So are there any questions first of all? No? All right. Just making sure that the audio is working here. All right, so to start, I'm going to skip the first one because it is a repeat of something that you did in one of your labs, FizzBuzz. The FizzBuzz problem is where you print out numbers 1 to n. It's a generalized FizzBuzz, so 1 to n here where it's parameterized and you're given a command line arguments. And then you're given 2 primes, and the old FizzBuzz is 3 and 5, and you have to print out fizz if the number is divisible by the first prime, buzz if it's divisible by the second prime, and then FizzBuzz if it's divisible by both. So unless we want to absolutely want to see that, I was going to go on to the more complex ones. No? Okay. So there's lots of text analysis tools out there that have a lot of different applications, spam detection, fraud detection, etc. And one basic step to each of those is a character frequency analysis. For this exercise, we'll write a basic program that reads in a file as a command line argument, and then goes through and counts up the number of A's, counts up the number of B's, counts up the number of C's, etc., regardless of whether or not they're uppercase or lowercase. So if it's not one of those alphabetic characters, then we'll of course ignore it. This gets into file input and string processing and basic loops, right? So pretty much everything that we've done up to this point, except for searching and sorting and stuff like that, we'll have to use in this exercise. So for the first step here, let's see. We give character count. Oh, I don't have, yeah, here, character counter. In this case, that year I did give, basic starter files here. In this case, it was, well, to do header documentation, and we name it charcounter, right? And our usage here is that we take in a file name as a command line argument, right? And if that's not there, then of course we exit, okay? It's just some simple starter code here. So now if it were me, again, and I'm going to recommend that you do this, if you're taking the final exam, you bring all of the code all of the good code, all of the bug-free code that you've written throughout the semester to the exam, because if you want to, you can go ahead and bring those functions to bear. For example, one of the functions that you might want to use is load up the contents of the file, right? Cut, paste that function that you've already written, put it in here, and half of your job is done. Right? I don't have that luxury here because I didn't write it. Right? I'll assume because I want to do a review here. Let's review how we can actually open up a file and process it, in this case, character by character. Right? So, to open up a file, of course, I need a file pointer. File F star, or star F, right? And I will open up this file, fopen, for reading, right? And I'll open up arg v sub 1 because that's my first user provided argument, okay? And I will open it up in the mode of reading that file, okay? R. Now I will do some basic error checking here. If that file opening failed for any reason, it doesn't exist, it doesn't belong to me, I don't have permission, whatever, then we can echo an error message and immediately stop. Printf error cannot open file, end the line, and be done. Right? Or we can exit with an error code of 2 because we exited with error code of 1, meaning bad command line arguments. Error code of 2, bad file, or something like that. Okay. Now, how do I read it? I could read it line by line, or I could read it character by character. In this case, since I'm counting up the characters, let's read it character by character. Okay? I will need a char C to actually read a character. How do we read a character from a file? Do we remember? How do we read a line from a file? Get, right? That's file get string, a string being the entire line. If I just want one single character, though, it's going to be get c, right? And we pass it the file pointer, and it returns a character, an ASCII text character. What does it return when we get to the end of the file? Do we remember? EOF, right? So while c is not equal to EOF, right? Then I'll go ahead and get the next character, the next character, the next character, whatever, right? Now I'm going to go ahead and do that, oops, sorry. I'm going to go ahead and do that inside the while loop here, all right? Now initially, if you want to, you can go ahead and initialize this to something that makes sense. The null terminating character if you want, or H or C or whatever you want, right? It doesn't matter because none of those will be equal to the end of file character. The end of file character is not even an ASCII text value. It's usually -1, but there's no guarantee on that. It's some negative value. Yeah?
So when that gets to the end of a line, like how does it know just to go down to the next line? What does it read?
So there's an A, B, C, N line character, right? It reads the N line character, and then it knows to go to the next one, right?
Okay, so if you were to do like F get S, then it would
It
read
would-
everything up until the N line character. And then
Remember that there's another parameter there, though, for F get S, right? It's the number of characters, maximum number of characters to read, right? So that's what, because you read it into this buffer, and you want to ensure that there's no buffer overflow.
So F gets F just gives like a buffer, like puts the whole line in a buffer,
Mm-hmm.
like an array.
Yep, exactly. An array of characters, yes. But this one, you don't have to specify, there's no possibility of overflow because it's a single character, a single byte, right? All right. Well, once I've got that, I need to count. Is that an A? Is that a B? Is that a C? Right? So first of all, since we are going to make no distinction between uppercase and lowercase, let's go ahead and convert it to lowercase. How can I do that? To lower, right? Or to upper, either one, right? Now, what is it going to do to a character that's an apostrophe or an exclamation point or something like that? It'll leave it unchanged. The only reason I'm doing this is so that I can treat uppercase and lowercase the same. Now, I do want to ignore it if it is an exclamation point or an apostrophe or something like that. So how can I tell if I should actually count this? If C is an alphabetic character, ... then do something with it. Yeah, the same C-type library here that allows me to convert it to a lowercase. I do what? Is alpha, right? Let's make sure by reading the documentation, and that's why it's an open book, open note test, right? Is alpha C. Or I could do, let's see if the man pages has it. Man is alpha. All right. All right, too much to read. Is alpha. Checks if it's alphabetic. In other words, you could. We'll do that trick here in a second for another reason, though. But yeah, if you want to, ASCII table. Let's pull that up just to have it ready for us, right? You could check if it's between 65 and 90, or I guess we already converted it to lower, right? So then you'd only have to check, is it between 97 and 122, right? So you could do that, but why? You've got is alpha here, right? If is alpha C. Either one, right? That's a little bit cleaner, though. Now, if it's an A, I want to increment a counter for A. If it's B, I want to increment a counter for B, C, D. Should I create 26 variables and initialize them all to 0, and then have an if C is equal to A, if C is equal to B, if C is equal to C, ... Should I? No. What could I bring to bear here?
The ASCII table you just pulled up somehow.
Yeah, so it starts out at 97 here, right? So I could create an array that's big enough to hold any ASCII value all the way up to 127 here. 120, so I could create an array of 128 integers, right? And then ignore most of them. Or I could create an array of only size 26, right? So let's do that. Int char count, right? And of size 26. Now, normally I would say don't do something like that because that's a static array that's created on the stack. We're only in the main here. If I were doing this inside of a function and needed to return it, this is a big no-no. If I were doing something that required thousands of integers, that's a big no-no. But it's only 26 integers. It's in the main. There's no big deal here. Now, what's in that array right there as far as line 22 goes? Anything, question mark, right? So what you could do is you could use that 0, 0, 0, 0 kind of syntax to initialize everything. But I believe that if you do it like this, it'll also initialize all 26 of them to 0 because I've specified the size here. Don't quote me on that. We'll find out here if it works, okay? How does that help me? Yeah, I could use C as an index variable on char count, so C++. Now we do have to be careful here. What if it's lowercase a? 97. Is that a valid index here? If this were 97? Nope. So what could I do to ensure that C, 97, would actually be shifted up to be 0? 97, subtract 97. There you go. Plus plus. Right? Once I'm done with that, I'm done with the file. What should I do? If I close it. Now here's where the output happens, right? For int I equals 0, I is less than 26, I plus plus, right? For each value in that array that I've created, I'm going to want to print something that looks like this. The character and then the count. Copy. Here's my header though. Printf, character, count, and the line. If you want to, you can tab over here or something like that, make it look as pretty as you want. Right? Otherwise, printf, I'll be %c/%c because I'm going to be uppercase a, lowercase a, and then the count. Right? And so %d and the line. Oops, there we go. How do I get those characters? Well, char count will be my last one, right? But how do I get this one and this one with respect to I here? Lowercase is I plus 97. Yeah, so what I could do is the same trick, but in reverse. To get the uppercase, it'll be I plus, what is it, 65, right? And then to get the lowercase, it'll be I plus 97. 65 and I plus 97. There we go. Let's see if that works. Oops. I don't know what the difference between last week it was looking perfectly fine. I don't know why it's not looking nice today. Anyway, I'm going to go ahead and touch a file, testtxt. And let's go ahead and refresh this. How could I easily test something like this? I could mash my keyboard, but then I don't know if it's correct or not, right? So I could mash my keyboard 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A's. 1, 2, 3, 4, 5, 6, 7, 8, 9. B's. C's. Just for variety here, Z's, right? Or maybe 1Z, X, Y, Z. Bunch of numbers interspersed everywhere that get ignored. A bunch of, tab character maybe. There we go, etc. Yeah, good point. Let's have some capitals in there. BB and A. X, Y, Z, 1Q. Capital Q though. All right, GCC, char count. At this point, I don't even remember how many I typed, so that was a terrible, terrible test case. I should have written it down. Oh, sorry, I forgot a comma somewhere. There we go. A dot out, of course it's expecting a file name. A dot out, test.txt. There we go. XYZ, all ones, that looks good. Q, I put one Q in there. And then it should be 10, 9, 8. Looks good to me. All right, questions on that? No? All right. Design and implement a C structure, forget about the Java, this is a different course, that represents a book, which will be represented by the title of the book, the author of the book, both first name and last name, the year that the book was published, and the goodreads.com rating of the book, which is a numerical score. I think it's a 5-star rating, so you can go from 0 to 5, 5 being the best. Okay. Say what? I'll go double. Yeah. So it will, but yeah, you can. It's an average, so you can have 4.75. All right. Let me go ahead and get rid of that and rid of that. We give you a .h file to start out with and a .c file telling you exactly the functions that you have to write. Looks very, very familiar at this point. You've done this now in class for, we did it for faculty. In the pre-prepared video, I think we did it on a student data structure. In your hacks, you did it for an airport, all right, et cetera, et cetera, et cetera. Whole bunch of different ones. So let's do it for a book. Right? Remember that it's the title of the book, which is going to be a char, star, right, title. Right? And we have semicolons at the end of each one of these. The author of the book, both first name and last name. Now I could get fancy and I could have yet another structure that represented an author or a person. But if it's just the first name and last name, who cares? Those are just strings. Right?
Do we have to make them separate, or can we just put like one, like just the name,
Like this. That's what I'm going to do. Again, I could get fancy and write another structure above this that represented a person, an author. But if I'm not going to be sorting by their, birth date and their height and a bunch of other things, there's not really much point. Right? The year that the book was published, and then finally the rating of the book. Well, we already said that the rating, I'm going to make it into a double rating. What about the year? Int. I like that. Simple. It's not a full date because it's not a month, day, and a year, although I could reuse those from the demonstration that we did before. That is a nice, quick way of representing this piece of data. If you were doing this in a real system where it was much more complex data, then sure, go ahead and go and split those out. That process is called normalization, and we don't need to normalize it just for this, though. At least in the context of a database, it's a normalization. Hey, those all look familiar, don't they? That's exactly what we just designed our book to be here. Now, if you'd want to, you can go with author, first name, author, last name, like I did here. All right, and I'll go ahead and do that, just to disambiguate it. Okay. Create book, init book, book to string. CMP by author year, CMP by title, CMP by rating. Generate books, deep copy, string, and print book array. And guess what? We gave you the generate reports, but you have to finish it. And what else did we give you? We gave you the deep copy print string copy function and the print book array function. Right? Simply calling your other functions over here. Right? So all we have to do is implement each one of these by itself. Right? So how would you implement the create book? Remember that it's going to return a pointer here to a book. So what am I going to have to do? Dynamically allocate it. Is this big enough for everybody in the back? Big enough now? Okay. Book, star, and B. equals to book star Malik. Right? And how many books do you want? Just one. But how many bytes does a book take? That many. And you can go one, or you could just leave it like that. Right? Now what I need to do is I need to set all of those variables, the title, the author's first name, author's last name, to what I've been giving up here. Right? Except that I've also got this init function down here. If the init function were done for me, all I would need to do is what? Or init book. Pass in that book, B, and everything else that I was just given, title, author, first name, author, last name, release year, and rating. And then return B, and you're done. Right? That was the most common, not error, but that was the most common bad practice that we saw in those hacks of folks repeating their big chunks of code that did the exact same thing over and over and over again. Don't do that. Right? You write it once, you reuse it. That's why you put it into a function. Okay? Now we actually have to do it though. Right? So how do I copy the title into that book? Well, do I use the dot operator or do I use the arrow operator here for the book? Arrow, why? Book star a pointer.
So if it were like an int, would you use dot or like?
No, I mean you're still going to use release year is equal to the release year, right?
So you use dot when there's no star.
Right. If it's book B, right, then it would be B dot release year, right, is equal to whatever, right? Some medieval book there. All right. Otherwise, book title is equal to title. Is that right? I mean, that's right in one sense. What kind of copy is that for the string? It's a shallow copy. Fortunately, we have a nice string deep copy function given to you. Let's use it. Over and over and over again. Title, author, first name, last name. Big cardinal sin there, don't copy pasta. But I did. It's simple enough. Right. Book. Rating, that's just a regular old primitive type, a double, so is equal to rating. There we go.
What's the string copy?
Say what?
What's the string copy function?
Yeah. We gave that code to you though.
Oh.
Right? We wrote, there is a deep string copy function in most string libraries. I don't know that it's interoperable though. It's not part of the standard. It's like an extension or something. Right? So we give it to you deep string copy or whatever. Right? And all it's doing is malloking something, the appropriate size, y+1 for the null terminating character, using strcpy to copy s into the copy, and then returning the copy. Okay? All right. Create book, init book, and I guess return. There is no return value here, but it's still best practice to return explicitly. All right, book to string. We're probably going to want to print each one of these things out. So let's go ahead and do it in a nice little, nice little formatted, a columnized format. So the title, the author last name, comma, first name, the rating maybe in parentheses, and then the release year or something like that. I don't know. Right. Let's go ahead and go with printf first. %s for the title. Right. In fact, we can go ahead and say 30 characters for the title. And then we'll go ahead and go %s for the last name, comma, space, first name, %s. The release year, we'll go ahead and go with %d. Why? Because it's an integer. And then we'll go ahead and go with %.2f for the floating point number representing the rating, the Goodreads rating. Right? And then end line? Well, no, we'll leave it like this. Right? And then book to string, b. How do I access that last, or that title? Again with a arrow. B, last name, author last name, sorry. B, author first name. B, year, release year. And B, rating. There we go. Now, if I were just to print like this, where is it going to print to? To the standard output. I don't want to print it. I want to print it to a string. So is there another printf that I can use? sprintf. But I need to print it to some string first. Right? Just like fprintf, I could give it a file handle right here instead. sprintf, I can give it a string to print to. So now one way that we saw a lot of people do, and it's perfectly acceptable as long as you do it correctly, is going through and counting up the number of characters in title, count up the number of characters in last name, count up the number of characters in first name, count up 4 for probable release year of this millennia, right? And rating, well, okay, it's going to be between 0 and 5, but with 2 decimal places of accuracy, so that's 1, the decimal place, and then 2, so that's 4 right there, right? And then you have to go through, okay, well, there's 1 space there, 2, actually, there's going to be a lot of spaces here if we pad it out with 30. I've already lost the count. Right? What's the easy way of doing this that we suggested in class? Create a temporary buffer that is large enough to hold any reasonably titled book. Right? Then you can print to that buffer. Then you can copy that value into a dynamically allocated string and return that. But remember, we have a deep string copy. We can just simply go ahead and return whatever that returns from temp. Cool? Is there going to be a memory leak here? At least in this function only. No, why? This is statically allocated. What happens when you return from the call, the function call? The stack frame gets destroyed. 1,000 bytes isn't going to break the bank. Yeah?
We need to, in this case, test if, like, what we pass is null, and then, like...
And you could, so if B is null, return deep copy of, I don't know, how do you want to do that? Null? There you go. Something like that.
Would that be, like, on the final, when we get thrown things like that, like in the grader, where we'll have to check?
Now I have to remember what I wrote. None of the TAs have tested it yet, so I don't know if I can answer that question. I wrote it so how I would write it, and I also wrote the test how I'd write the test. You're not going to have that problem.
Okay.
No. You can encourage your TAs to actually do the exam like I've asked, though. None of them have stepped up to do it yet. All right, so that's good enough for that, right? CMP author by year, right? Do we have, here, generate report. Do I have a book demo? Yeah, I've got a book demo here. There we go. I even gave you test data, or I gave them test data, whoever took this exam, right? We created a bunch of 5 books here, right? Harry Potter and the Deathly Hallows, Pachinko, The Name of the Wind, The Wise Man's Fear, and The 3-Body Problem, right? 2 outstanding books, 2 tolerable books, and then 1 I'll let you guess which one is which, in my opinion. Anyway, those are actual values from goodreads.com, okay? All right, so generate your reports. If we've done everything correctly, we can go ahead and compile all these together, book.c and bookdemo.c. I don't think that we're not done yet because of all those others, but what else is wrong? Release year, I must have misspelled that, and yeah, that's the only thing that's preventing us from testing this. Oh, okay, fine. Release year. There we go. And did I get that correct everywhere? find out. Release year, release year, release year, release year. Okay, that looks good. There we go. So it's only warnings because none of our comparators are correct, but I don't think that we're using our comparators yet. It's just going to print out the actual books here. All right, here's the first, sorted by title. Oops, okay, fine. I'll go up here. First, sorted by title, is that correct? Now remember, we're blindly sorting this, so if this were an actual library, they would take out articles like A and the, right? But since we're sorting it by alphabetic order, then the will count in that. Is that correct, though? Is it? And so when you look at N, W, and T, is that in alphabetic order? Doesn't look like it to me. By author year, it's the exact same one because we haven't really done anything with it, right? So if you take a look at this book demo here, what are we doing? We're generating all these reports. That generate reports is done for you, except for you need to sort the books by title. Now, if I had done those comparators already, how would we actually use them here? I want to sort them by title. What's the function I use to sort? QSort. Right. And what do I pass into QSort? The array, right? The number of elements in the array, n. What's the third one? Size of each element, book, right? Why? Because it needs to swap these two books. It needs to know how many bytes are over here, how many bytes are over here, so that it can copy exactly that many bytes. And finally, the comparator, hey, CMP by title, hint, hint, right? Likewise, you need to sort them by the author's last name, first name, then by year oldest for books of the same author, okay? So QSort, and I think that we've got what? By author year. All I have to do is replace that comparator. And all I have to do is replace this comparator. There we go. Now I don't like the way that it formatted this, so I'm going to go back to that toString method, or function. Let's go ahead and kick it up to 40. And also, let's move it to the left. Or there's your left. How? By left justifying it. Okay. Say what? You don't have to. I mean, you could, so that you could get their last name, comma, but then there'll be a bunch of white space for the first name. I mean, if you want to treat those as different columns, yeah, but here's what it'll look like now. That's good enough. If I were to do that so that it was truly one column, I would move the last name, comma, first name, put that into another temporary string, and then format that temporary string to exactly the right width so that the years and the numbers all line up too. Although if I were going to do that, I would probably separate the first name and last name out into two different columns anyway. If you want to do that, we can do that instead. Left justify 20, left justify 20. Ooh, there. Good enough. Take out that comma though. Okay. Now all that's left is to actually do these comparators. Let's do by title first. Right. Typecast. How? Const. Book star, right? And I've already used A and B, so I'll use X and Y here. Is equal to const book star A. I'm typecasting A as a book pointer to be exact. And I'm going to typecast B to be the same. All right? Then I need to compare it by its title. Right? In fact, I should read the documentation here. What's the expectation? Just orders them by their title. Right? So, return a simple call to strcmp. String comparison for x's title and y's title. That's it. What about by rating? Here I will do an if-else-if statement here. If x is, and what is the order? Highest to lowest, right? So let's go ahead and go back, and if x's rating is greater than y's rating, then it should come first and we should return something, what? Something, string comparison? Say, well, no, I mean, anything positive, anything negative, or 0. 3.5 minus 3 is what? 0.5. And when it gets returned, is 0.5 is going to be what? 0. The difference trick doesn't work, right? Then 3 minus 3.5. Ceiling is going to be 0 again. Or 3 minus 3.5. It'll never work, right? What you need is not a ceiling, floor, truncation. None of those things work. What you need is a signum function, which is simply just looking at the sign and returning -1, +1, or 0. And there are some languages that have that signum, the sign of the number, right? You can write it if you want to, but might as well just return 1 in this case. Remember, we want it to be highest to lowest. So 5 and 4. 5 is greater, 5 should come first, therefore we return something negative. Else if x's rating is less than y's rating, then I'll return something positive. Else return 0. We also don't want to use equals equals as one of our two cases, because 1/3 times 3 is not equal to 1. You have floating point issues there. So don't get fancy. Yeah, you have an if, else statement here, but that's what's necessary. Yeah?
So for that same reason, if you don't want something to be changed, can I do like equals less than?
Like less than equals?
Yeah.
Less than or equal to,
'Cause like
you could do something like that, but then you wouldn't be able to break ties later on. Like if there are two things that are equal, that gets into what's called stability, sorting stability. And so say that we have two 5s here, 5 and 5. Well, this one's perfectly fine, so is this one, right? You have not defined a total order on those two things. And so sometimes you run the same sorting algorithm over and over again, and it'll end up thrashing these two back and forth, right? It's not, and that gets into sorting stability. Like, generally you want to prefer stable sorting algorithms, or you can make any algorithm stable by simply making sure that all ties are broken uniquely. So that there's this 5 and this 5, but this one came first, so it remains first, and we won't thrash them back and forth. Okay. Last one. Again, same typecast here. By author, then by year. Right? Except that, don't I already have an author? No, I don't have an author, sorry. Right? I thought I did, never mind. Right. So, since I'm going to be breaking ties, what I'm going to do is I'm going to put this into a result. Right? strcmp of x's author last name, y's author last name. And here is where you can do a trick. If the result is 0, in other words, they were both by, what was it, Patrick Rothfuss? Rothfuss? What's his name again? Rothfuss, right? Rothfuss, right? So if they're both by Patrick Rothfuss, then we need to go to the first name, right? And so result will be equal to strcmp of y's author first name. There could be Smith Jane and Smith Zoe or something like that. And Y's author's first name. And I screwed up, that should be X, right? There we go. Now, if the result is still 0, that means that we've got the same last names, same first names, and now we need to break the tie by year here. And I forget what the order was. Let's go ahead and read the documentation. Oldest to newest. So 1980 and 2020, right? That should be the order. So here, I will say, okay, yeah, you can go ahead and do the difference trick now. Why? X is release year minus Y is release. I don't know if this is the correct order. We'll have to think about this. Release year. Right. Result is equal to the difference. Now, why is it safe to assume that the difference trick will work here? It's explicitly an integer, and there aren't going to be any books published in the year -2 billion and in the year +2 billion to risk overflow, right? They're all going to be within, the biggest difference is going to be, say, 10,000 years or something like that, okay? I don't think we have any published manuscripts over 100,000 years old, certainly. Right. Now, is this the correct order? Think about this. 1980 should come before 2020, 2022. So 1980 minus 2022, if we subtract it that way, what will we get? Equals -40, right? And that means that 1980 would come first. That's the oldest first, right? So it looks good to me. So let's return that result. Let's make sure it works. And I've got to spell everything correctly. All right, if this worked, here, let me clear out the output. If this worked, all of the orders should be corrected. Title, HP, and then NTW. Okay. Author year, looks like Lee, Liu, Rothfuss, and Rowling. Right? And now the two Patrick Rothfuss books are the oldest, 2007 and 2011. That looks good to me too. And then by rating, 2604, 06, 55, 58, and 62. Back to the drawing board. Right. First of all, what was it? What was the order supposed to be? Highest to lowest. Is that highest to lowest there? Well, that's not in any order that I see at all. Right. So let's come back over to rating. There we go. Oh, I see why. You got me playing around and screwing around with the code. And what should we have done? Greater than. There we go. And now that looks much better. Right. So if you can write a comparator to always return some random number, 0, +1, or -1, and then you've got a randomizer. It'll sort it in random order. That's it. That was that final for that year. Got a half hour left. You can try on another, start on another, the next final, or do something else. Okay. I mean, if we get done with that one early too, though, we could. I've got 10 years of finals here, and not a single one has been repeated. So. Yeah, if you want to see the random, S random, time, null, that's seeding the random number generator with the current time, so that in book we can go ahead and create a comparator here. CMP random, there we go. We don't even need to concern ourselves with what they are. let's see, int r equals random mod 3. That'll get me 0, 1, or 2. And now what I can do is subtract 1 from it, because 0, 1, or 2 subtract 1 will get me negative 1, 0, or 1.
Is the function not rand anymore?
Oh, is it rand?
I don't know.
Man, rand. I forget what the difference is. We'll try random first here. There we go. And then copy, paste. What do I call the random one? CMP random. There we go. CMP random. Random. There we go. And I will need to make sure that that's in the H file too. Oh, and then the other thing we could do is look at advent of code too. I'll do documentation on that later. Okay, fine. Nope, over here. I need the time library for that. Oh. There's random. So Harry Potter, the two Rothfuss, Li Liu. There, you see it? It's changing each and every single time. Come on. Rothfuss, Lee, Rowling, Rothfuss, Liu, Rothfuss, Rowling, Lee, ... So it's not guaranteed to be a great randomization. Certainly not cryptographically secure randomization, but it's good enough for testing. And you definitely want to have a much larger pool of examples, because there are only so many there are only 125 permutations of 5 things. All right, we can save it. Any questions? No, no questions online that I see. So if you want a preview, again, advent of code, and also so this is 2021. So the one the first one was just given all these numbers in a file. You have to count up the number of times they increase, because it starts at 199, goes to 200, that increased. 210 down to 200 though decreased, and so you have to count how many of those there are. And then I think I did the second day one time. Okay, so this one's a little bit different. Forward, down, and then you have to calculate where you are after that, starting at, say, the origin or something. These are all pretty simple exercises. What was 3? Okay, bitwise stuff. I don't want to get into that. So we would probably end it on day 2. What was the other one? There was another one, though. Maybe it's this. Each day is actually 2. So once you get this one done, you have the same input, but it's a slight variation that usually if you do it the quick and dirty way on the first one, then it makes the second one harder. So you have to do it correctly, like good style wise, right? So that you can reuse stuff that you used on the first star to get your second star. Has anybody done advent of code before? No? Okay. All right. Otherwise, I'll give you a preview of what the, where is it? Of what the other final was. Assignments, fall, 2. Here it is. So here's the problem. So we're on UNO campus, but you don't have a football team anymore, so. Yeah, haven't had one for what? At least, what? 2012? Right, this is all 10 years, that's what I thought. Anyway, back in 1997, when you still had a football team, there was a football team down in Lincoln that won the national championship, except that they didn't. Does anybody know the history there? Yeah, it was the shared national championship. Why? Because the top two ranked teams didn't play each other. All right, there were two, the championship Orange Bowl against Tennessee, and they creamed them with Scott Frost as their quarterback. And they finished #1 in the coaches poll. That should have been enough for them to be declared national champions, except for Michigan was declared the champions by the AP poll. This is before the BCS that we have now, right? So Scott has asked you to produce a report that proves that Nebraska should have been crowned national champions. How? We give you all of the team scores for 1997. And what you're going to do is you're going to go through that and all of the game scores through for that year. And you're going to go through and produce a report that looks something like this. The team, their win-loss record, and their win percentage, and then the point difference. That is, the points scored, the team scored versus minus the points that were scored against them. So for example, Nebraska scored 329 more points. The difference between them, the point difference, was 329, and Michigan was 203. So clearly we scored or didn't allow as many points against us by almost a factor of 2 versus Michigan. Right? So by that ranking, Nebraska is clearly the national champion of 1997. Right? The idea here is that you're going to produce a full report of all teams that have at least 11 games. They used to play 11 games back then, right? During the regular season. I scrubbed it out of all the championship data and stuff like that. So it was only 11 game season for everyone. Poor old Rutgers down here, who we would eventually start meeting in the Big Ten conference 20 years later or something. They didn't win a single game. What was their record last year? Does anybody follow football?
Yeah.
What was their record, Rutgers?
It was better than it usually is.
Better than it usually is. Was it better than 4 and 8?
Maybe. I think they were like 5 and 7.
Oh, what a difference 25 years makes, huh? Anyway, they also had some, I think, some chemical help back in '97. So.
Oh yeah.
They had the best training that money could provide. Anyway,
Just juice up the formulas.
that was just orange juice. Anyway, the CSV files look, something like here. We can I can show you what they look like. Otherwise, we can wait for next time here. I can bring them in, copy paste them, and they look something like this. Where's the teams? So we've got 145 teams here in Division 1. Each one of them has a unique UUID. UUID is a universally unique ID that is randomly generated. It's randomly generated using cryptographic randomization so that the probability that any two UUIDs are generated that are the same is extremely low. And so I just generated a whole bunch of UUIDs here. For example, North Carolina State is associated with this UUID. Where's Nebraska? So there's Nebraska associated with this UUID. It's just a string, right? So that you can look up their games over here in this table. Right? There were 642 games in this data set that I downloaded at one point. And where's Nebraska's game? So there's Nebraska. They were at home because they're the second team there. They scored 29 points, and they shut out whoever this was. I'd have to go back to the other file to look up that UUID. Right? Oops. Where's another Nebraska score? Nebraska defeated that team 38-24 at home. 77-14 at home. Right? There, they were away, and they won 49-21. I don't know who they are. We'd have to look in the other file. Right? For this particular one, let's find out. Who did they defeat 49-21 at their place? Baylor. Ooh, that feels good. That feels right. I'd like to get that feeling again at some point. So, that's what we'll do next time. Yeah.
I don't know if this would be asking too much, but would there be any way we could like have access to one of these previous finals that wasn't rewritten, just to like go over ourselves? Would there be any way we could do that, or is it?
I mean, we're broadcasting, so you could always go back and take a look at the handout there. I could post that handout to Piazza if you want.
Okay.
Yeah. Otherwise, let me know, and I'll post it later today. Make a post to Piazza, and I'll post this handout.
Okay.
Yeah.
Just to clarify, I was wrong on the
Oh.
record of Rutgers.
Okay. Rutgers in 2021 had
They
a
did in fact go 5-7,
5 and 7,
but it was good enough to get them to a bowl game.
and they lost.
They lost to go to 5-8. So
Which bowl game was it?
the Tax Slayer Gator Bowl.
Gator Bowl. So that was Florida.
Wake Forest.
Oh,
Tax
okay. It was
Slayer-
just in Florida then.
Yes.
Okay.
Jacksonville.
Tax Slayer Gator Bowl.
That is the Tax
What
Slayer
is that, $1 million
sponsor.
pot or something?
Probably.
All right. When was the last time we were in a bowl game? Does anybody know?
5+ years ago.
Yeah.
Longer than that.
When was the last time we were in a Big Ten championship?
2012.
Yeah,
Wisconsin.
yeah. Well, yeah. We've both times that we've appeared, it was in Wisconsin, hasn't it?
Yeah.
And we've lost both times.
Yeah, both times was bad. I want to say it was 2014, if I recall. I know so much.
The first one, I was definitely not working here because they played at my company's Christmas party, and nobody cared about the party at all. So, turn on the damn TV. Shouldn't even have come. But all right, we'll go ahead and pick it up there next time then.